Hello everyone, welcome to Tutors once again. Today we're going to start a new series and which is on calculus. I'm going to start first on differentiation, okay? And this first video is on the rules and the basic functions of differentiation. It's on the rules and basic function, basic functions of differentiation, basic function of differentiation. Of course, this is also a series. So just stay tuned, relax with it. Okay, good. First, you may ask, what is a derivative? What is a derivative? I will tell you. A derivative measures how fast. It measures how fast something is changing. Measures how fast something is changing. Measures how fast something is changing. Okay. So even if you have heard that of this statement, it might not be that clear to you. But so I'll give you an example. So for example, when someone is driving, when you're driving, you're in a bus. So what moves? You are changing your position with time. So what is changing with time? There is your position. So speed is your derivative. Can you see? What is changing is what? Your position at that point. And it's changing with what? With respect to time. This is a derivative. Okay? So, first, let me just give a standard definition of derivative. The derivative of a function of x, the derivative of a function of x, of a function of x at a point, at a point x equals a, is the instantaneous rate of change. Is the instantaneous rate of change. Instantaneous rate of change of f at that point. Of f at that point. Good. So we've done that about our brief introduction on that. Now let's move on to the rules and basic functions of differentiation. Let me outline the rules for you so you can see. Now the first rule we're going to look at on it's on the power rule, constant rule, and the sum rule. Power rule, constant rule, and the sum rule. First, what is the power rule? What is the power rule? Now, the power rule states that if a function of x is equals to ax raised to power n, the derivative, which is f prime x is derivative, or what you all know as what? Dy dx, is given as what? N times a times x raised to power n minus 1. Good. So, a quick example on that. We're giving us, if y is giving us 3x squared, what is the derivative? So you say dy dx is equals to, this is our n, 2. So you say 2 times 3 times x raised to power 2 minus 1. You can see we subtract 1 from n. That gives us what? 6x raised to power 1. And anything raised to power 1 is itself. So if it's x raised to power 1, you have what? X. 2 raised to power 1 is 2. Anything raised to power 1 is itself. So you have 6x as our answer. 2. If you are given y is equals to 4x. 4x. Now, what is the power of on this? Can you say any power? You cannot. Some people might not be able to say power, but the power here is what? One. Many a times in mathematics, but anyway, we have a number because anything raised to power one is itself. We don't usually write raised to power one, make it visible. But this looks like this. It can be written this way. So next you can say 1 times 4 times x raised to power 1 minus 1. And that gives us what? What's 1 times 4? 4. X raised to power 0. Anything raised to power 0, anything raised to power 0 is 1. Anything raised to power 1 is itself. Just note these two things. Good. So if I say x raised to power 0 is 1, or anything raised to power 0 is 1, anything raised to power 1 is itself. So you have 4 times 1, and the answer is what? 4. So your own work to do under power rule are the following. So first you do this. If y is equals to 2x5, what is dy dx? 2. If y is equals to, okay, let me make it a bit tougher. 3x raised to power 2 over 3. What is dy dx? Now we've come to the end of power rule. We're going to move into constant rule and sum rule. We're going to move into constant rule and sum rule. So now let's talk about constant rule and sum rule. Now constant rule, what does constant rule state? The constant rule, C-O-N, constant rule. The constant rule states that if y is equal to a constant, for example, then the y dx of that constant is equal to 0. The y dx of that constant is equal to 0. Good. So, which means the differentiation of any constant in a function is equal to 0. So simple. So I can give you a, okay, just for an example first. If I'm given that y is equal to 4, and now tell us to find dy dx, the answer will be what? 0. Because in this place, there is not, there's nothing that is changing. Y is not changing as x is changing. There's no x in this function. Are you with me? So anything that is not x in this function is 0. I'll give you a clear picture with the next example. Example 2. If I give you a function of y is equals to 3s squared plus p, okay? And I tell you to find dy dx. Do you know that between y equals 3s squared and p, 3s squared will change because it is involved in y as x is changing, y is affected. Okay, so that means that our differentiation will work on this, but in this scenario, because there is no p there, right? P is a constant, so differentiation of this will be what? 2 times 3, 6, right? The x, then 2 minus 1 plus differentiation of p. P is a constant, that is what? 0. And it give us what? 6x raised to power 1, and that's what? 6x, right? So finally, I will just give you a straightforward hint that I use. Okay, so if I give you something like, let's say y is equals to 2x squared plus z. Now, if I tell you to find dy dz, if I tell you to find dy dz, in this scenario, you are only able to differentiate what is z because we are doing y and z. Anything that is not z is a constant. So irrespective of what is here as 2x squared, you are taking it as a constant. And I told you that what? The differentiation of a constant will always give us what? 0. So here, in this scenario, dy dz will not be 4x. No. It's turned to what? 0 plus. Now, this I told you that we can differentiate this way according dy dz. That's same thing as z raised power 1, which is 1 times z, right? Z is same thing as what? Z raised power 1. So 1 times z, then 1 minus what? 1. Okay? That gives us what? Z raised power what? 0. 1 minus 1 is what? 0. 1 times z, z. So answer is what? 1. We've come to the end of constant true. The next, we're going to just round up our what? Our sum rule. Now, on sum rule, sum rule tells us that if you have a function that includes many functions, let's say ux plus vx plus w as a function of x, you have different functions. Good. And you want to find dy dx. It's telling us that what? The differential can be done to each of these functions separately. So you differentiate du separately, you differentiate dv separately, and you differentiate what? The w separately. Let's go into a question so that we can understand what I'm saying. If y is given as 3s squared plus 6s cubed plus 4x, yes, plus 4x. What I'm saying is that what? You differentiate this guy, you add it to the differential of this guy, you add it to the differential of this guy. So you have dy dx is equals to 6x, right? 2 times 3, you know that, plus 3 times 6, 18, square, plus what? 4, right? For anybody asking how that get 4? 4x raised power 1, right? So 1 times 4, 4. 4x, then 1 minus 1, 0. Anything raised power 0 is what? 1. So 4 times 1 is what? 4. Good. So that's the sum rule. So either you have positive that join them together, or you have negative. Okay. So for example, if I have like 2x 4 minus 3x squared, so you differentiate this guy started by what? Differential of this guy. So the y dx will be what? 8, 4 times 2, 8. 8s cubed minus what? 6x. Good. So work to do for you. Work to do. So y is equals to 3x 4 over 3 raised to power 4 over 3 minus 2x 5 plus 8x cubed. Ensure you put down the answer in my comment section. I appreciate it. Thank you, and stay tuned for the next video. You have our quotient rule, product rule, and function of function. Thank you.